It's nice that it's Friday afternoon, quite late, and you're still here listening to Cisco server innovations and something about our cloud strategy at the end of the presentation as well. So my name is Tommi Keskitalo. I'm coming from our Espoo Cisco office. I'm responsible for Cisco data center architecture sales in Finland, Estonia, Latvia and Lithuania. So Baltic area and Finland. So I'm today going to tell you about our latest server innovations which we launched in beginning of September. And what does it, we actually launched some new categories of servers we haven't had before. So what does it mean for you? So you will learn in a couple of minutes. So Cisco's data center architecture is basically like this shown here. So we launched Nexus data center specific purpose switches somewhere in 2007. Then we launched UCS servers 2009 in US and 2010 in Europe and rest of the world. On top of that, we have built by ourselves lots of intelligent management solutions, and we have also made some acquisitions in this area. So Cisco's way is typically so that if we don't innovate something in the very beginning by ourselves, then we just buy the company readily made and integrate it into Cisco. So two ways to success basically. What we call these architectures is unified fabric, that's the switching part, unified computing, unified management. Everything's unified. First about Cisco UCS, our server platform, and also our NAND flash-based storage system, which we just, that is one of the acquisitions Cisco made like a year ago. We acquired a company called Invicta. So what is specific in Cisco servers? Why we have been so successful especially in blade servers? We are at the moment #1 in US, #2 in worldwide and Europe, #2 in Finland as well. I don't know, I haven't seen any official figures from Estonia, but I think that we are having pretty good market share here as well, in blade technology especially. So why we are so successful, even though we have been in the market still something like 4 or 5 years only? Reason is that we have been able to uniquely integrate computing, networking and virtualization into the same platform. Very tight integration so that everything, this is like a software controlled servers in a way that we can manage all the parameters in the server. They are something like 100 parameters, 96 as far as I remember. We can program them into the hardware. Our hardware is just sitting there waiting so that some system administrator is giving the kind of soul for this hardware. We program network parameters, storage parameters, computing parameters. We make a profile out of that. That can be ESXi profile, Hyper-V profile, some bare metal profile for Oracle server or whatever. We put it in the server, just drag and drop, and in 10 minutes the server will boot itself as an ESXi server, Hyper-V server, whatever you ask it to do. So that's the kind of Cisco's innovation, and that's why customers like us in summary. So traditionally we have had this kind of platform that we have fabric interconnects, which are the switching part of our system. Then we have UCS manager, which is living inside the fabric interconnects. That's, by the way, the only management point in the whole system. Then we have a dummy chassis, only fans, powers. Then we have 2 of these fabric extenders, which are a kind of remote line cards for these fabric extenders. You don't have to manage them. They are just giving you the bandwidth, but you don't manage them. We put them there in the chassis, put the servers there, put our virtual interface cards there, and we have a system. When you need to expand this system, you just have multiple of these chassis, still having only one management point there in the top of the picture, so the fabric interconnect. That's the only place you manage. And our management, and by the way, you can also have not only blade servers but also rack servers in the same system. So you can combine blades and racks and have still single management point. And everything comes free of charge when you buy the hardware. There's no additional software licenses for this type of management. So our user interface looks something like this. Well, then we launched in September some new versions of our blades and racks. So this is the most commonly used blade server nowadays, B200 M4. What is new there is of course this new Intel processors which came into the market around at the same time. Faster memory, still same bandwidth, 80 gigs per server. And then we have some new software innovations here in our third generation virtual interface card. What this virtual interface card actually means is that we can, by software, kind of slice this physical 2x10 or 2x40 gig interface card into virtual NICs or virtual HBAs. So we can divide this one physical interface card into 256 pieces. And what does it mean is that basically when you have virtualized environment like virtualized with VMware or Hyper-V, you can connect multiple virtual NICs for your virtual machine. And from network administrator's point of view, it looks like you would have a physical machine. So you can see the traffic there, which typically the network edge has been in the server. In our solution, we can give a network all the way down to the virtual machine level. In certain applications it's a good feature, in certain applications you don't need it. But for example, if you are running virtualized SAP, if you are bypassing this hypervisor with our virtual NIC technology, then we can basically get 10% more power out of the same hardware, just as an example. Same for our rack servers, C220, which is 1U rack server unit, C240, which is more storage capable rack server, 2U, 26 disks altogether. Those are the kind of best selling products in typical servers, what we are selling, B200 blades and these two rack models. This is a new category of server. We launched this kind of dense storage server where you can have several hundred terabytes of storage in 4 rack unit form factor. And why would you buy this one? Any idea where this kind of thing would be useful? Well, original use case came from our customers in US who are cable operators there. They wanted to have, because by the law, you need to have in US, if you are providing this kind of virtual digital box service for your customers, or so that you're storing your movies into the network instead of your set-top box. You need to have physical copy for every single customer. So if 5 million US customers are looking some TV series and they make a recording out of that series, there needs to be 5 million physical copies of this same movie or same 1 hour program or whatsoever. You can understand that how much storage capacity is needed there, and actually the storage capacity then needs to be in a very close to the consumer. It cannot be in a centralized data center because none of the networks could tolerate that kind of traffic if you are streaming it with a single stream. So they wanted to have a dense amount of storage capacity near the customers, and that is the basically answer for that particular request. There's lots of other use cases for example as well, so that if you have a latest version of Exchange server in your company, so you know that the Exchange server that is taking care of this data protection in a software layer, so that you have 2 active nodes and 1 standby node. And actually the Exchange software is taking care that you have copies of your mailboxes all the time. So that if you lose one of these servers, you don't lose any mailboxes. That is very handy for that kind of case. So in general, all applications which are taking care of the data protection in a software layer can utilize this kind of, I would call dummy storage. Because this is not like, there was an EMC guy previously here. EMC is making very sophisticated storage boxes where data replication, write protections and mirroring and all kind of stuff is done based on EMC's innovations. We have a much simpler solution here. Software layer is taking care of these data protection features, but this is also in a very different price category than these EMC products, for example, or any storage vendors products. So this is very cheap storage in a massive scales. If you have any of these applications, this could be a solution for you. Then completely new category as well, M-series. This is our cloud storage, cloud server platform. And what does it mean? In traditional data centers, you typically have a piece of hardware here. Then you have a hypervisor, whether it's VMware, Hyper-V, KVM, whatever, you name it. And then you have a number of workloads on top of that. So that is how enterprises are running their typical applications. But now in this cloud era, most of the services are starting to come from the cloud. And in cloud, if you have a popular game in this kind of cloud platform, for example, it could be so that this is some quest or clash of clans or whatever you like to play. It might have a very huge amount of users. Therefore, it needs, just for this one application, there's a need for maybe hundreds or thousands of server hardware units behind these applications to keep it powered and give power for this application for all these users. That's the kind of sweet spot of our M-series. Gaming is one example. Big data applications is another example. Lots of things. But anyway, the technical idea here is that one application, lots of hardware to run it. As a comparison for traditional enterprise, that one server, lots of applications. Just completely upside down. And what's our innovation is this in this kind of era? I think that you have heard about HP Moonshot or HP Apollo or those kind of platforms. We have done this very differently. And of course, I feel that we have put some more intelligence into our design. So we have taken all the peripherals. We have not just shrink the server for minimum form factor and put lots of them in one chassis. We have actually taken out all the peripherals, which are network adapters, hard disks, fans, power units. They are in kind of one container. Our building block is 2 rack unit server, basically. Then we have another container here, which is CPU and related memory. So we have a cartridges which is having two CPUs and memory for both of those. And they are completely separated. They are linked together with our Cisco System Link technology. I told you about this VIC card, this VIC card. Actually, our System Link technology is using the same kind of technology. I'm not going to go into details in this time frame how it works actually, but anyway, we have borrowed this technology from that. So as a comparison, if you would build this kind of cloud scale computing platform from traditional way using 1U servers, for example, you will have number of PSUs, number of fans, number of cables, controllers, RAID controllers, NIC cards, HDDs, and it would look something like this. A rack full of servers. This is our solution for the same requirement. We have 16 servers in this 2 rack unit container. And when we build the solution based on this, we have this very same fabric interconnects I told you in the beginning of the presentation on top there. Then we have a number of these 2 rack unit containers here, up to 20 in one system, and we can have 320 servers in one logical manageable unit. So basically this is shipping on half racks or full racks and so on. It's a system for very high capacities. And of course, based on the traditional design comparing to this one, because of our programmable hardware solution, we can provision much faster than in traditional solutions. Of course, there's very few peripherals compared to traditional solution. Power efficiency is better, and therefore also TCO is better. This is how it looks like in the first generation. This starts shipping now in December. It's not shipping yet, but very soon. So we are in the first generation using Intel E3. And I told you about the Moonshot, for example. Moonshot is using some, I think that they have a variant of E3 as well nowadays, but they used to have only Atom and those kind of processors. What does it mean for the application is that E3 is capable of running very same applications as E5 Intel. If you have Apollo Moonshot type of approach that you are using some other CPUs, you have also need to convert your application to run these different processors. So same applications which you are nowadays running with rack servers can be run here as well. We are using only SSDs, so 4 SSDs max per 1-2 rack unit chassis. And this is how the computer cartridge then looks like. 1 CPU, related memory, etc. So if you need to have a big number of bare metal servers, for example, this is very cost efficient solution. Idea why we are doing this, why we are introducing this kind of thing is that we can have a much cheaper price point here than having number of 1U rack servers. It's a completely different price point. So just the summary, any application which is capable of this kind of grid computing type of workload is potential for M-series UCS. Then something which could be more attractive for normal enterprise users is UCS Mini. So UCS Mini is having the very same capabilities as the UCS I presented to you in the beginning of the presentation. But what we have done differently is that we have shrinked these fabric interconnects into the chassis. So now in UCS Mini, this is a one working unit, one manageable unit. And it can grow from here. I will show you how. So basically when you start building Cisco UCS server, if you go this upper path, you end up in the traditional UCS, which has been existing since 2009. If you build this lower way, you end up in the UCS Mini. And why we have introduced UCS Mini is again because of the price point. The lower one is much cheaper in small capacities than the upper one. The upper one scales better, but the lower one is cheaper. Same software functionality, nothing changed in that sentence. So just very briefly, we have in this new fabric interconnect, we have a 4x10 gig uplinks, or you can use this as for rack server connections as well. Then we have a 1x40 gig link for connecting another chassis or again number of rack servers. So in the first version, which is already shipping, which we have already been selling in Finland and proposing for some cases in Baltics as well, is this, so that you can have one chassis for blades, then you can have a maximum 7 rack servers in the same manageable unit. Somewhere in end of December, early January this year, so in a couple of months, we are able to do this so that we have a maximum 16 blades and on top of that 4 rack servers. Very handy, very good price point. If you have nowadays a need for maybe 4 or 5 servers, typically the only capex kind of just sustainable solution has been to buy 4 rack servers or 5 rack servers. Nowadays you can buy UCS Mini and we can hit the same price point with 4 or 5 servers than you used to do with the one or 2 U rack servers. Then something about Invicta. This is our storage solution. We are not competing with EMC, NetApp, those guys which are our friends. We are actually introducing a new category of storage, which is this kind of 3rd generation flash-based, NAND flash-based storage system, so that if you need to have a very high IOPS but not so much data, that is the solution for you. We are not trying to eliminate rotating disks here. So typical characteristics of this kind of solution is that in a 2 rack unit form factor you can get 250,000 IOPS. Then you have multiple of those, then you get more IOPS. You can stack them and put them together. We have also software inbuilt in the operating system. We have inbuilt data deduplication, for example, so that all the data which is stored here is by default deduplicated. What is specific compared to some other vendors' similar systems is that we can write and read almost in the same pace. Typically, this NAND flash-based solution, because of the nature of the flash technology itself, is much faster to read than to write. But we have made a specific algorithm. I'm not explaining how it works now. We can have an offline discussion about that if you like. But because of this algorithm, we can reach about the same level of writing than reading. And that is a kind of a differentiator for our technology. This is also a very cost-efficient system because one Finnish telco was comparing 10 different similar type of systems, what they call 3rd generation flash-based storage arrays. And per gigabyte our system was the cheapest. Actually this operator didn't choose any of the systems. They just wanted to know that what are the real price points, because they are planning that maybe one day all their virtualized environments are migrated away from the rotating disks completely. But in this phase they were not satisfied for anybody's pricing, but Cisco was the lowest priced alternative compared to all of them. And you know that Cisco is typical, we are not typically targeting for the lowest price point. We are competitive pricing, but not typically the lowest. So even I was surprised that we are the lowest priced. So maybe I should go to work with Dell or somebody. So. All right. But we can have also, like I told, so there was this variant where you can stack number of these 2 rack unit boxes, make this kind of scalable system. This is not any technical limitation, it's just productization limitation nowadays that we are not shipping bigger boxes than this roughly 400 terabytes. Technically we could make a petabyte box easily. And if there's customer demand, we will do it. But this is the current system. So just as an example, if you have a number of workloads here, you can make, using our UCS computing, our UCS Invicta storage, a very nice solution, because the management comes from the same source. You can use UCS Manager, UCS Director, and manage the whole system, provision it, provide more capacity in a very efficient way. So then, just a summary about our management solution. So, rack server management and blade server management blade and rack server managers, UCS managers, they are coming kind of free of charge. When you buy the hardware, you will get the management solution on top of that for free. Also, if you have multiple domains, like multiple data centers, you need UCS Central in order to take this one service profile from data center 1 to data center 2, drag and drop it there, and start running your application there. You use software called UCS Central, and that's also free, up to 5 domains. If you have more than 5 data centers, then you have to start paying for that. On top of that, we have UCS Director, which is a kind of the whole data center infra level management solution. We can manage servers, storage, network devices, virtualization layers, so hypervisors as well. And not only Cisco branded devices, also competitors' equipment, our partners' equipment like Neta, EMC, also those V-blocks which were mentioned in the previous presentation. So it's very, very handy. We just sold a big implementation for Finnish National Healthcare, or how is it called, Kela anyway, who is taking care of every Finnish citizen's pension, for example. They are using UCS and UCS Director. Well, then at the end of the presentation, I will spend some 5 to 7 minutes for our cloud strategy and our Intercloud Fabric product, and after that you can have some questions if you like. So Cisco's cloud strategy is that we are not building this kind of traditional IaaS cloud ourselves. We are not providing capacity from our own data center for anybody. We are not competing with our partners. Our partners are here, Cisco powered clouds. These are the guys from CGI, guys from British Telecom, from Deutsche Telekom, to mention some bigger names in Europe. Also some local guys. I don't know, I guess that there's nobody in Estonia yet in our Cisco powered cloud program, but hopefully when we have this same session next year, there will be somebody. I will tell the benefits in a minute. Then we have this kind of provider clouds. In what I mean provider clouds, this is Azure, Amazon, Google, SoftLayer, those type of global big cloud players. Then this is your own data center in the top, your private cloud. And then we have Cisco Services, our SaaS services. For example, if you have heard about Webex, Meraki, those kind of Cisco services, they are typical Cisco cloud services. We are building all the time more services. We will have SAP HANA as a service, disaster recovery as a service. We just launched, for example, with Tieto in Finland, that we are developing Internet of Everything or Internet of Things together. We have service for that, a cloud-based service as well. So our ecosystem comprised so that if you have a private cloud, we will provide you a portal. This portal is shipping in before end of this year. Not yet, but very soon. You can use this portal for your own applications. You can, of course, use those Cisco applications which you like in your portal. Our partners can publish their applications into our portal. So for example, if CGI, who is part of our Cisco cloud ecosystem, if they have a very handy application for something, for healthcare or whatever, and you need to have that application, and you have your Cisco portal, so you can use that application, CGI will get their compensation, and you will get the service. On the other way around, if you are Cisco powered partner for us, and you have a very nice application made here in Estonia, you can publish it for worldwide delivery. So companies in US can use it, and you will become compensated about your innovation in that. So that's the way how we're building our ecosystem. And then something about this middle part, Intercloud Fabric. This is a product. It's a software-based product where we are enabling virtualized workloads to move around these clouds. How it works, very briefly, I'm not going to go into technical details in this presentation, but we are happy to provide very detailed technical presentation about this topic if you like, someday offline. So basic idea is that any hypervisor, any hardware platform in your own data center, we can take your virtual machine to any of these clouds, Azure, Amazon, soft layer, also for this our partners, Cisco powered clouds. So basically anybody in our ecosystem. So it's hypervisor agnostic, hardware agnostic. You will keep the same VLANs, same IP addresses if you are moving virtual machines from your Hyper-V based cloud to here, for example. So we are basically extending your own cloud into Amazon's data center or Microsoft data center or wherever you want this extension to take place. Just simply, what are the components of this software solution? All these are basically, it requires two parts, which are virtual machines. So in the service provider part, we called a component called Intercloud switch. So this is the provider's part. Then in your own data center, if you are the end customer or having your own private cloud, you have a Intercloud extender. And this is the management part of this solution. It can be in your control if you are this end customer here, or if you are this service provider, you can also provide this whole system for your customer as a service. From the business model perspective, it means that if you are the end customer, you want to control that where your virtual machines are, whether they are in your own data center or whether you want to lease capacity from somebody else. You will control using our Fabric Director that where your virtual machines are located. If you're a service provider and providing this as a service, so without even your customers knowing, you can transfer their workloads between those clouds. Maybe for your own data center, or maybe sometimes you run out of capacity, or you get capacity somewhere cheaper, for example from Amazon. Then you can put your customer's workload into Amazon and nobody even doesn't need to know about that. So that is very simply how it works. And of course there's end-to-end security all the time. So basically what our value proposition here is that we provide choice, freedom to locate your workloads wherever you like them to locate. Consistency, so that your VLAN addresses, your IP addresses, which you have in your own data center in your workload, will remain even though you are transporting your workload to Amazon or Azure. Control, you can control where your workloads are, and compliance, so it's end-to-end secured solution. This product is shipping now, so it's already available. We have a number of references, not yet in Finland or Baltics, but in Europe and mostly in US. Most of our cloud ecosystem partners, these big names I mentioned, they are already using this technology. They can provide it, like British Telecom, Deutsche Telekom, CGI. So that was pretty much what I wanted to say. And now if there's any questions or comments or counter arguments about any topic I presented here, so I'm happy to have this conversation now. By the way, we have a local team here, which is at least half of the team is present. So we have Lauri Makke and Kaupo Sarapik, who are local Cisco guys. So if you want to have any additional information, I think that through Atea persons, you can reach those guys and they can then answer for your questions, and if they can't, then they can get some support from Finland. So thank you.